Hey everybody, this is Ben and welcome back to another Leetcode video. And today we're going to be looking at problem 482 titled License Key Formatting. So you're given a license key represented as a string S that consists of only alphanumeric characters and dashes. The string is separated into n+1 groups and n dashes. You are also given an integer k. Now we want to reformat string S such that each group contains exactly k characters, except for the first group, which could be shorter than k, but still must contain at least one character. Furthermore, there must be a dash inserted between two groups, and you should convert all lowercase letters to uppercase, and we'll return the reformatted license key. So we'll talk about that. We'll look at some pseudocode, we will walk through an example, and then we'll code up a solution together. Let's get right into it. So the objective here is fairly simple. We're given a string S of characters and dashes, and we are given an integer k. String S has n+1 groups and n dashes, and we want to reformat string S so each group contains exactly k characters, except for the first group, which can be shorter or equal to k. The first group must contain at least one character, though. Now, there will be a dash inserted between each group. Further, all characters in the result should be uppercase. I believe the best approach here is to create a new string entirely using a string builder object. Note that the prompt says each group must have k characters except for the first if applicable. Now how can we do this? It can be done by starting from the back of string S rather than the front. We'll add one character converted to uppercase at a time to our string builder, and then we'll reverse the result when we return. We can keep a counter of how many characters have been added to the string builder, and when the counter equals k, we know that we have completed the group. We can then add a dash and reset our counter to 0, and we'll repeat this process until we fill the string. Note the dash is always added in this algorithm when our counter equals k. In some cases, we'll end up with a dash at the end of our string builder prior to reversing it. We need to check if the final character is a dash, and if so, we'll delete it. Then we return our string builder reversed, which will be the correct answer, since we filled the string builder from the back of string S rather than the front. That is why reversing it is required. Let's go ahead and look at the pseudocode here. First, we'll create a string builder object. We'll initialize a counter variable to 0, and then we'll use a for loop, every character in string S starting from the back. We'll initialize character temp to the current character in S. If temp does not equal a dash, we'll iterate our counter, and then we'll append temp to string builder. Note that temp is going to be the current character to uppercase. Now, if counter equals k, we'll append a dash, and we'll reset our counter to 0. That represents the completion of a group. Then we end our for loop. If string builder length is greater than 0 and the final character in the string builder is a dash, we remove the dash. Then we return string builder to string reversed. So let's go ahead and walk through an example here. Now our given string is 2-5g-3-j, k equals 2. So first we'll create our string builder object sb. We'll set our counter to 0. Then we have a for loop here, starting at I equals s.length minus 1. I is greater or equal to 0, and I minus minus. So this will cover every character of s starting from the back. So starting at I equals 7, our character temp, remember we're always converting to uppercase here, so equals j. Temp does not equal a dash, that's true. So we iterate our counter, which now equals 1, and we append temp to our string builder. So string builder now just equals j. Now if counter equals k, that's false, so we can move on. Now when I equals 6, our character is a dash. If temp does not equal a dash, that's false, so we go to the next iteration. I equals 5, our character equals 3, temp, so 3 does not equal a dash, that's true. Iterate our counter, append our temp character, so now SB equals J3. If counter equals K, this is true. 2 does equal 2. So we append a dash, now we're at J3 dash, and our counter gets reset to 0. I equals 4 is a dash, so we go ahead and skip through that. I equals 3 is a G, so that does not equal a dash, that's true. Iterate our counter to 1, append our character, J3-G. Counter equals K is false, so we move on. I equals 2, char temp equals 5. This does not equal a dash, that's true, so we catch this if statement. Counter, we need to iterate it, now equals 2. Append our character, 5. Counter equals k, that's true, so we append a dash and we reset our counter. When I equals 1, that's a dash, so we move on. When I equals 0, our character equals 2, that does not equal a dash, is true. Iterate our counter, now equals 1. And we append our character J3-G5-2 is appended. Counter does not equal k. Counter equals k is false. So now we end our for loop. Now, if string builder length is greater than 0, that's true. And string builder character at sb.length minus 1, that's our last character, equals a dash. I need to put that there as well. Equals a dash, that's false. Thus, this if statement evaluates to false. What we're doing here is we're checking if the last character in our string builder is a dash. If so, we need to delete it. Note, we check the last character because this is prior to reversing our string. And then we'll go ahead and return stringbuilder.reverse.toString, which gives us 2-5G-3J, which is the correct answer. Let's go ahead and code up a solution together. So first we create our string builder object, SB, and we will create a counter variable. I'm going to call it cur. We'll say for in I equals s.length minus 1, I greater equals 0, I minus. And now we'll set char temp equals character to uppercase s.character at I. Now if temp does not equal a dash, we need to append it. So we'll iterate our counter. We will append temp to our answer. If cur equals k, that's when we know a group is over, and we can append a dash, and then we can reset our counter to 0. Now in the end, we'll say if sb.length is greater than 0. So one of the edge cases for this, the string technically can be all dashes, which means our result string builder would be empty. So that's why we need to check for this so we don't have any compiling issues by trying to access a character that doesn't exist in the second part of this statement. We'll say equals a dash. That's when we know we need to remove. So we'll say sb.delete, sb.length minus 1, sb.length, so that removes a substring, which just represents one character in this case, given our parameters. We'll say sb.reverse.toString. Let's go ahead and run the program on our examples. And that works. We'll submit, and sometimes it does run slower when recording, it seems like, but it actually ran well there. So our runtime is 10 milliseconds. That's about 94% faster than most submissions. Memory usage, 45 megabytes, less than about 74% of submissions. So overall, this is a very efficient solution, making a new string with our string builder, and then just reversing at the end, removing the final dash if we need to. So thank you very much for watching, and have a great day.